Hello and welcome back to my channel, as it were, and today we're going to be doing a maths problem from the online Oxford Maths Club. And we're asked to find how many solutions for x does the equation cos of 240x over x squared plus 4 equal 1/2 have. And we're given 5 options. So the way we're going to attack this, because we know that cos is an even function and continues forever, so it will go something like that. Not well drawn, I grant. But anyway, it will keep going forever. So if it has a solution here and here, it will also have a solution here, 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 here. So what we're going to do is we're going to find out where the function of y equals 240x over x squared plus 4 has maximums and minimums. And we're going to use 2 methods for that. The first is through differentiation by chain rule. The second way is putting y equal to a constant and working with the discriminant and putting that equal to 0. So, first the chain rule. So we know that y is equal to this, and I'm going to rearrange that and say that y is equal to 240 times by x squared plus 4 over x to the minus 1/2. But of course I can rewrite this bit in here as x plus 4x to the minus 1. And what I'm going to do is I'm going to let u equal x plus 4x to the minus 1. And y will be equal to 240 u to the minus 1. So dy by du will be equal to minus 240 u to the minus 2, which is the same as minus 240 over u squared. And then du by dx will be equal to 1 minus 4x to the minus 2, which is the same as 1 minus 4 over x squared. And the whole premise of doing this dy by du and du by dx is that when you multiply them, dy by du times du by dx, you have on the numerator and on the denominator you have one of the same thing, so those will cancel, and so then you get dy by dx. So what we're going to do is we're going to multiply them. So minus 240 over x squared plus 4 over x all squared times 1 minus 4 over x squared. And what we're going to do a little bit of rearranging. So we're going to get minus 240 x squared over x squared plus 4 all squared. That's just because when you divide by a fraction, you flip the fraction and multiply. And that will be multiplied by x squared minus 4 all over x squared, because this one here turns into an x squared. So x squared divided by x squared is just 1, so we can turn this 1 into an x squared and put the whole thing over x squared. This x squared here will cancel with this one here, so let's make them cancel. And so we get minus 240 x squared plus 240 times 4 over x squared plus 4 squared. And we know that this will be equal to 0 at turning points. So what we're going to do is put it equal to 0. Now the denominator won't actually play a factor, because if if the numerator is equal to 0, the whole fraction will be equal to 0, and the denominator can't be equal to 0 because that would be undefined. So I can write this as 240 times 4. I'm not working it out because I don't need to at the moment. I will if I have to, but I don't need to at the moment. Minus 240x squared is equal to 0. And that means I can take out a factor of 240, so 4 minus x squared is equal to 0. Therefore, x squared is equal to 4. X is equal to plus or minus 2, which means if it has two solutions for the maximum and minima, then I can put them back into the function. So 240x over x squared plus 4 when x equals 2 will be 480 over 8, which is 60. And when x is minus 2, that will be minus 480 over 8, which will be minus 60. So what our graph looks like is something like that. Not like I've drawn on the bottom. It is more like that, with maximums at 60 and minus 60. And what that means is that our correct answer would be, in fact, C, because it only has two solutions and it won't go beyond 60 because the function never goes above this point. I'm now going to show you the other method for finding how many turning points it has, or finding where the turning points are. But that's to do with not finding the x value, it's to do with finding the y value immediately. So let y equal a constant k. And so we have our constant k is equal to the function 240x over x squared plus 4. And we multiply through, so we do kx squared plus 4k is equal to 240x. Then we take everything onto one side, so we get kx squared minus 240x plus 4k is equal to 0. And we use the discriminant and we put it equal to 0. So the discriminant, which is just b squared minus 4ac, is equal to b squared, so 240 squared. I don't need to worry about the negative because any negative squared is a positive number. Minus 4 times 4 is 16. So 16k squared, and that is equal to 0. So I'm going to write 240 squared as 240 times 240. But I know that 240 is 15 times 16, so I'm going to take a factor of 16 out from everything. So I'm going to do 15 times 240 minus k squared is equal to 0, because I've just eliminated the 16, because 16 is not making this function equal to 0, because 16 is not equal to 0. So what I'm going to do here, because this looks pretty nasty, I'm going to split this into prime factors. So 15, just as prime factors 3 and 5, because that would be 5, and then it would be down to 1. 1's not a prime factor. 240 has 2, 120, 260, 230, 215, and then 3, 5. And so that means that we have 3 times 5 times 2 to the 4 times 3 times 5. And if we've multiplied these together, we'll get 2 to the 4 times 3 squared times 5 squared. And that will be equal to k squared. Because we had this minus k is equal to 0, minus k squared is equal to 0, therefore k squared is equal to it. And we can conveniently square root both sides. So we get 2 squared times 3 times 5, plus or minus that, is equal to k, or the y value at the maximum or minimum. And so 2 squared, 4 times 5, which is 20. 20 times 3 is 60. So k is equal to plus or minus 60, which is what we found earlier. And therefore, our function has only two maximums and minimums at 60 and plus or minus 60. Therefore, the actual equation has only 2 solutions. So that is answer C, as we saw earlier. Thank you for attending this video, and I look forward to seeing you all next time.